So Sally, where did the idea of biomimicry come from?
Well, the term biomimicry has been around for a long time, but it was popularised by a woman called Jeanrenaud in a book she wrote, which was published in 1997, I think, called Biomimicry, Innovation Inspired by Nature. But the word biomimicry, it comes from the Greek bios, life, mimesis, to imitate. So it basically means to imitate life. And it's a kind of idea that we need to learn how to work with the grain of life. But if you think about it, I mean, ever since humans have been on the planet, we've been looking at nature and wondering how nature works, and we've been copying it. When you go back to things like Leonardo da Vinci, and his drawings of things like, prototype helicopters back in the sort of 1400s or whatever, in the 15th century. People have always been looking at nature. People have always been wondering how nature works. The Wright brothers, the aeroplane, their idea of how an aeroplane should work was based on studying how birds fly. So we've always been looking at it. But the reason that it's become quite interesting now is, and has become popularised now, is that it promises, if you like, a new way of looking at nature, learning from nature that we desperately need. To learn how to be sustainable and how to live sustainably in the post sort of industrial period.
So is that its relevance to the MBA
That's
programme?
its relevance now, because we desperately need a new way of looking, new way of living that's working in harmony with nature in ways that are sustainable, because the last 100 years, because of fossil fuels, because of the way our attitudes towards nature, I suppose, the fact that we've just taken resources, the fact that we've just kind of chucked our rubbish out, has had huge impact on nature, and we desperately need a new way of thinking about it and how to work in harmony with it. So the biomimicry paradigm is a very compelling new story, if you like, of how to look to nature, how to learn from nature, and find new ways of living, producing and consuming.
Thank you.
And what's amazing about what she's done is she tells stories about nature. So they're very, very easy to remember. For example, the Swiss engineer used to take his dog for a walk up in the Jura in Switzerland. This was 60 or so years ago. And every time the dog went out for a walk, he'd get covered with these birds. So he'd come back, and as an engineer, he'd spend hours and hours combing all these birds out of the dog's fur. And because he was an engineer, he got really, really fascinated with it and started looking.
You've got a little hook at the end of it.
That's right, that's right. So actually what was happening was that it was getting stuck in the dog's fur. But it actually inspired him to think, well, maybe this could be like a whole new way of fastening things.
It wasn't Velcro.
It's Velcro. It's Velcro. And he took the idea around to all these French manufacturers. He thought if we could make a fabric out of it, it means we wouldn't need metal. We wouldn't need to dig metal out of the ground and heat it up and use vast quantities of energy. We could actually just use this very simple fastening mechanism. No one was interested for years and years and years. And then eventually the Americans picked it up, and it's everyone knows Velcro now, and NASA took it into their kind of engineering in a big way, and it went right up to space. But it's basically kind of endless stories about biomimicry, and that's the woman who kind of framed the concept.
Jeanrenaud.
Yeah, it's really fascinating stuff. This is a red-throated hummingbird that actually migrates 600 kilometres every year. And in one migration, it has to cross the Gulf of Mexico. And it's tiny, it's only as big as your thumb. And it goes something like 35 miles an hour, but like a taxi around the city, Before it goes off on its migration, it has to get its fuel. So it goes round and it collects, for its fuel, it collects the nectar from the flowers all around in the ecosystem. And as it's collecting the nectar, it's pollinating all the rest of the ecosystem. So it's actually, in serving itself, it's serving something much bigger. It's serving its next generation. So there's food for its babies, and its offspring. But it's also serving the wider ecosystem, all the species in the wider ecosystem. So this design principle of life, creating conditions conducive to life, that's what nature does. And that's become like the central the aspirational design goal of the new paradigm. Just kind of, it's just little stories.
So that's in this outgoing.
Yes, how you
to the antithesis.
Exactly. Yeah. So it's really a series of fascinating. This guy here was the engineer on the bullet train in Japan. He watched how the Kingfisher went from low density to high density, copied the design principle, put it on the nose of the train. It now goes much faster.
So from the air into the water.
What was happening with the old train was it was going through a tunnel and creating an air bubble. When the air bubble came out, it popped and made a sonic boom, and it disturbed everybody for miles around. So you take the design principle from that, and you learn how to be more efficient, much more effective, use less energy, go faster.
So how does that relate to the MBA?
Well, it's because we're looking at innovation in business and different ways of different kind of sources of design inspiration. For this. So this is, for example, is the lotus that comes up through really, really muddy water. How does nature do that? And when it comes out of the muddy water, it's always pristine clean, doesn't use any chemicals, no nasty toxics going into the environment. It always remains absolutely pure. It has to, because it has to photosynthesize.
So how does it do that?
So how does it do that? So they find that the actual lotus leaf is covered with little bumps and everything, and the dirt actually gets rolled up and attaches to the water. And it just rolls off. It's a self-cleaning mechanism. So you don't need huge amounts of nasty chemicals to clean things.
And it's also the symbol of spirituality.
I know, that's why I love it. That's why I love it. So this company, Lotus Sun, has taken the design principle, created a paint based on the same design idea. So when it rains, the building is self-cleaning. It's all beginning to happen. There's endless. This is when you see any iridescent colouring, like a beetle, shiny beetle, or a beautiful peacock or a butterfly, you think it's got beautiful pigments in it. It actually hasn't. It's all just brown. It's the
lights being.
Yes, this is a new generation of creating colour without chemical dyes. They're incredibly toxic, but nature doesn't use that idea of creating colour. It uses refracting light, so it builds up layers of protein and the light's refracted. So that is actually brown, but it's the way the proteins are layered that builds up the colour. It's just keratin, it's just brown. It's bright blue, but in Europe we're phasing out many of the chemicals which we use to create colour, so we've got to find new ways of actually creating. And so there's all these kind of new ways of sticking. We've never invented anything as sticky as a gecko foot, this kind of pencil. Never invented anything that sticks underwater like blue mussels do, but we're beginning to learn now how nature does it. Health, no bacteria on this Galapagos shark because of the way that the material, the surface is arranged. It just disperses the bacteria. So people are saying, great, new things for the hospitals, It's very, very inspiring. And how to collect water when there's no water. Little beetles know how to do it in dry deserts. In nature, for example, CO2 is not a poison. It's a building block for building structures. And coral reefs and everything are made out of CO2 that's bubbled through salty water. It builds bottom up, bit by bit, incredible structures, these corals. And it was actually a dentist who was dealing with dentures who discovered that if you actually take CO2 and bubble it through salty water, you get a cementitious material that's like cement. So we've got huge problems with CO2 in the atmosphere, but actually we can start to make cement out of it, just copying nature's recipe. I find it fascinating because it's a whole new way of thinking about our industrial processes, which are much more life-friendly. Because we've always learnt about nature in chemistry and physics and biology, but this is actually trying to learn from it. It's a slightly different way of looking at learning from it rather than just about it, and seeing if we can extract that design principle and apply it to solving some of the problems we've got.
And it's moved so far from that sense of you raid nature.
Yes, exactly.
For what it's
Exactly, because we
doing,
never knew, 100 years ago that we were going to have the impact on nature that we would have by what we were doing, but we do now.
The wisdom traditions that you're also interested in. Can you say that briefly?
Yes, I suppose when we talk about biomimicry on the MBA, what we're dealing with really is introducing people, business students in particular, to entirely new ways of looking at the world. So we're trying to introduce the idea there's a lot of wisdom in nature. If you kind of quieten down your own cleverness, if you quieten down your own cleverness and actually bother to take time, natural wisdom. So it's like all the laws, all the principles, all the ways of all the processes, all the cycles, all the interactions, the web of nature, all the interdependencies. There's so much to learn from that.
When you talk in that way, you're talking about nature's wisdom, and nature is a sort of separate idea from mankind. So you've got two distinct ideas there.
Yes, two distinct ideas.
One to learn from the other.
That's right. We actually, it generates quite a lot of debate within the class, because there are a lot of people around who think we're just part of nature. We're just part of nature. The problem in the past is that we thought we're above nature. So a lot of people have got a very sort of quite a sophisticated eco-philosophy, if you like, that we're part of nature. But because we're introducing ideas like we have consciousness and awareness which is distinct from that, and we can learn the patterns from nature, does that mean that we're something a little bit separate? So we actually set up a debate in the class to say, are we part of nature or are we apart from nature? And we get people to debate those kind of ideas.
Because the very fact we can reflect upon it and are conscious of it.
That's right.
In the way that an ant isn't reflecting on
That's
you.
right. And we can extract the patterns, we can learn from the patterns and apply them in a completely new way. So we don't actually go into the wisdom traditions, say, in this particular way of learning, but implicit in there is the idea that nature expresses a lot of wisdom, if you like. And then on the other side, in terms of the wisdom traditions themselves, we don't actually teach anything yet, but we're actually developing some course content around it, because people are very interested in exploring the kind of ethics, the moral dimension of decision-making in business, and that's such a great kind of source for those ideas. So I suppose what we're really looking at is wisdom wherever it comes from, It's not a very easy thing to interpret this. But if you put the Earth itself is something like 4.6 billion years old, our planet Earth. So if you take when the Earth was born as January the 1st, and if you take today as, the end of the year, 31st of December. So life first appears on the planet 3.8 billion years ago. That's the first sort of bacteria that came in. The fungi started appearing in November. And then in December, this is December the 31st, hominoids walk about 11 o'clock. And then Homo sapiens about it's nearly midnight, and the Industrial Revolution is like 100th of a second before the end of the year. So basically the story is that life has had 3.8 billion years of research and development, knows how to be sustainable. Knows how to be sustainable, otherwise it will just go extinct. It knows how to live with water, with the atmosphere, with the rocks, with all the systems and cycles. It just knows how to do it. Of course it does. But we've come along, conquering, not really, very, very young in terms of our understanding of physically live in the system. And actually we could use a bit of humility. And so, bees are something like 30 million years old. We're terribly young physically. And it makes you realise too that the Industrial Revolution and the use of fossil fuels, which has happened in the last 50 to 100 years, they call it the Great Acceleration in the 1950s, and the huge interruptions and changes we've made in the dynamics of life processes, just extraordinary. And yet we've had billions of years of life, before that, and it's such a short little window that we've actually managed to really change things around. But I see the positive side of that, because I think it actually will open our eyes and our understanding to the fact that we actually have a role to play in cooperating with nature.
Makes it retrievable, doesn't it?
So we have a responsibility to know how to work with nature, work with the grain of life rather than against the grain of life.
The grain, Everything works with the
grain of life, yeah,
except us.
exactly, yeah.
It's kind of human will, isn't it?
Yeah, yeah, but I think, you know, we're beginning to learn, I think, and maybe this crisis is a way of helping wake us up. So some of the principles are: it only uses energy from the sun, doesn't dig fossil fuels out of the ground, only uses natural materials, all the life chemistry takes place in water. It uses chemicals and it uses toxic, but only in tiny quantities, and never in quantities that destroy itself. It only uses life-friendly, gentle manufacturing processes, and there's absolutely no waste. Everything's recycled. You know, when the leaves, there's no such thing as litter in nature. The leaves drop off the trees, they go back and they nourish the whole system. So there's loads to learn from.
Who would have thought that about the lotus? Self-cleaning houses.
Self-cleaning houses, that's right, that's right. There's endless applications. It's just really observing the cycles of nature and saying, what can we learn from them?
Wow, thank you. Good.